Number 23, down to the last four here. When we see here we have denominators that are not factored, so we're going to go ahead and factor all the denominators, and so we do that so we can list our LCD. Our LCD is 2 times p minus 2. Each one of the denominators goes evenly into that, so we're going to multiply both sides by that. In fact, I'm going to go ahead and just visualize it right here, being multiplying both sides, or all three fractions, by that LCD, which means this denominator cancels, and so we're left with p squared minus 7p plus 12 minus, now only the 2 is going to cancel with that 2, and we're left with p minus 2, so 1 times p minus 2, and then we have equals, this denominator cancels, and we're left with whatever the numerator is, and so we have p squared minus 5p plus 4, and so this becomes one of those problems where you just have a lot of work, a lot of algebra. Just be careful here, collecting like terms. First thing we're going to do is in solving this equation, we want to get rid of the parentheses. We already got rid of the fractions. Now we get rid of the parentheses. Now we combine like terms. On the left-hand side, we have a negative 7p and a negative 1p. That's a negative 8p. And then we have this 12 and this 2 that get added together to give us 14. On the right side, all the terms are already, all the terms have been combined. We can't combine any more like terms on the right-hand side. So we can see we subtract p squared from both sides, and so those are going to go away. That's kind of nice because now the equation converts from a quadratic equation to a linear equation. Those are much easier to solve. Now we're just going to go ahead and separate the variables because we don't have a quadratic anymore. So we want to separating the variables, separating the terms, meaning put the variables on one side and put the numbers on the other side. So we're going to add 8p to both sides, and then we're going to subtract 4 from both sides. And what we end up getting is 14 minus 4 is 10, and negative 5p plus 8p is 3p. And when we divide both sides by 3, we get p is equal to 10/3. I forgot to list my restrictions up there, but I can see the only restriction would be that p is not allowed to equal 2, and that's not what we got, so we are done. All right, we're getting there. Number 24, LCD. Let's go ahead and factor out a k squared, and we're going to get k minus 3. Here again, k squared times k minus 3, and we have that k minus 3 there. So our LCD is k squared times k minus 3. So k is not allowed to equal 0. K is also not allowed to equal 3. So when we multiply both sides of this equation by that lowest common denominator, we can see this k minus 3 cancels, and so we're left with k squared times 1. And then we have the entire denominator cancels, and so we have 1 times 1. And then over here, same thing. The entire denominator cancels with the LCD, so we're left with 5. So at this point, we can see we have a quadratic equation, but we don't have a linear term, which means we can go ahead and subtract 1 from both sides, and we don't have to factor this. We could gather all the terms to one side and factor k plus 2 times k minus 2. But if we notice here, without a linear term, we can separate the quadratic term from the constant term, which means at this point we can go ahead and take the square root of both sides. And when we take the square root of both sides, don't forget, we get k equals plus or minus 2, because really, ultimately, this the square root of k squared is the absolute value of k. Square root of 4 is 2, and then the absolute value of k equals 2 means that we have two solutions, both 2 as well as negative 2, and that's it.